is our lecture number 4. In last lecture we have seen the dimensions of different physical quantities, just like velocity gradient, like that. Today we are going to see the uses of dimensional analysis. Uses of dimensional analysis. In that, first use we consider here to check the correctness of physical equation This is the first use of dimensional analysis. See here, in this we consider in any physical equation, if the dimensions of all the terms on both sides are the same, then that equation is said to be dimensionally correct. This is also called principle of homogeneity. This is the first use of dimensional analysis. That is, in any physical equation, if the dimensions of all the terms on both the sides are same, then that equation is said to be dimensionally correct. And this principle we call it as a principle of homogeneity. Suppose we consider examples. First example we consider, suppose V equal to U plus AT. This is the first kinematical equation where V is final velocity, U is initial velocity, A is acceleration, and T is time. Now we write here dimensions of LHS, left hand side, is equal to dimensions of velocity. We write like this: m0 L1 T minus 1. This is the dimensions of LHS. Now dimensions of RHS, right hand side. See here, U, that means velocity, I will write m0 L1 T minus 1 plus A means acceleration, m0 L1 T minus 2 into time, I will write like this: m0 L0 T1. Or if we combine all these, we get here m0 L1 T minus 1, m0 L1 T minus 1 plus m0, see here m0 I will write m0 L1 and L0 I will write L1 T minus 20 plus 1, I will write here T minus 1. And if we combine this, see here, this summation is not like our normal summation. I will take here, suppose m0 common, L1 same thing, and T minus 1 That means dimensions of RHS is equal to M0L1 T minus 1. That means if we observe these two steps here, this dimensions of LHS, dimensions of RHS, then I can write here, therefore dimensions of LHS left hand side is equal to dimensions of RHS, and which is equal to, we can write here, M0 L1 T minus 1, which is equal to M0 L1 T minus 1, and therefore given equation is dimensionally correct. Suppose we consider second kinematical equation. You know, V square is equal to U square plus twice AS. See here, V is final velocity, I will write here M0 L1 T minus 1 is equal to M0 L1 T minus 1 plus M0 L1 T minus 2 acceleration and M0 L1 T0 for displacement. That means we can write here, suppose M0 L2 T minus 2 is equal to M0 L2 T minus 2 plus M0 L1 and L1 I will write L2 and T minus 2 T0 I will write here T minus 2. That means M0 L2 T minus 2, these are the dimensions of LHS, is equal to M0 L2 T minus 2 plus plus. That means this we can combine these two. In case of dimensions we write common M0 M0 one time, L2 L2 also one time, and T minus 2 for one time. That means these two dimensions of LHS I will write, suppose dimensions of LHS exactly matches with dimensions of RHS. This is the second example. Suppose I will write here third example. Third kinematical equation, you know, that is S is equal to ut plus half AT square. See here, this is displacement. That means M0 L1 T0, dimensions of LHS, is equal to, this is velocity, M0 L1 T minus 1, then for T, M0 L0 T1, dimensions of time, plus M0 L1 T minus 2, dimensions of acceleration, and M0 L0 T square, that means T raised to 2 I will write here. Or we can write here, suppose M0 L1 T minus 1, M0 L0 T1, if we combine M0 with one time, M0 L1 L0 I will write L1, and T minus 1 and T plus 1 I will write T0 plus, see this product, M0 L1 L0 I will write only L1, and T minus 2 T plus 2 I will write T0, and if we combine again these two I can write here M0 L1 T0 means M0 L1 T0, these are dimensions of LHS. Therefore I will write here again dimensions of LHS is equal to dimensions of RHS. That means we have considered here three kinematical equations, and we checked the correctness of these three equations. I hope you all understand this first use of the dimensional analysis, that means to check the correctness of physical equation. Now I will consider second use. Second use that is to establish the relationship between related physical quantities. This is the second use, that is to establish the relationship between related physical quantities. Now, suppose we consider here for a simple pendulum, if we consider simple pendulum, then in case of simple pendulum, we consider different physical quantities, that is period denoted by T, then length of the pendulum denoted by L, and acceleration due to gravity denoted by small g. Then we can obtain the relation between these three for the simple pendulum. Now suppose I will write, suppose I will write T proportional to L raised to A and T proportional to small g raised to B. I will write here, that is T proportional to L raised to A and T proportional to L g raised to B. Here A and B are unknown, and by using dimensional analysis we have to obtain the values of A and B. Therefore I will combine here T proportional to L raised to A, small g raised to B, and therefore T is equal to K. K is the constant of proportionality, it is unknown. Then L raised to A, G raised to B. This is the relation. Now we consider here we have to obtain the values of A and B. Now we write the dimensions of both sides. See here. Dimensions of time, you know, that is M0, L0, T1, which is equal to K. This is the constant, it have no dimensions. Therefore I will write here K as it is into. Then L raised to A, length, I will write L0, L1, T0 raised to A. This is dimensions of L. And G means acceleration due to gravity. I will write here M0, L1, T minus 2. These are the dimensions of acceleration raised to B. Okay, I hope you understand this. That's dimensions of time, dimensions of L, dimensions of acceleration. Therefore, see here M0, L0, T1 is equal to K as it is. We combine these. Okay, M0 raised to A, M0. L1 raised to A, I will write L raised to A, and T raised to 0. Again, M0, L raised to B, and T raised to minus 2B. Therefore, I will write here M0, L0, T1, which is equal to K as it is. Then M0, this M0, I will write only M0. L raised to A, L raised to B, I will write here L raised to, that is L raised to, I can write here C, A plus B. And T raised to 0, T raised to 0 and T raised to minus 2B, I will write here T raised to only minus 2B. That is addition. And if we consider, if we equate or if we compare, suppose I will write here, compare left hand side and right hand side. Suppose comparing LHS and RHS, left hand side and right hand side, you compare, then we get here. See here 0 0, no problem. A plus B, I will write A plus B. This is the power of L on right hand side. L raised to A plus B, and here L raised to 0. Therefore A plus B is equal to 0. This is our first equation. And for T, see here minus 2B equal to 1. This is the second equation. Now from equation 2, B is equal to minus half. This is the value of B equal to minus half. Now we put this value B equal to minus half in equation 1. Therefore A plus B is equal to 0, A minus half is equal to 0, and therefore A equal to half. This is the value of A. Okay, A equal to half. Suppose equation number 4. And if we put the values A equal to half, B equal to minus half in this equation, then we can write here T is equal to K, L raised to half, B raised to minus half, or T is equal to K into square root L upon, L upon G. And by experiment, it is obtained that value of k is directly equal to 2 pi. We take value of k equal to 2 pi, and therefore t is equal to 2 pi root L upon G. This is the formula for period in case of simple pendulum. Here you take k equal to 2 pi directly. That means by observations it is obtained. And this is the limitation of the dimensional analysis. That means this constant cannot be determined by using the dimensional analysis. By experiments it is calculated, and therefore t equal to 2 pi root L upon G. This is the relation between related physical quantities. Here what is the use? We have written second use to establish the relationship between related physical quantities. That means related with time, length of the simple pendulum, acceleration due to gravity. They are related. And what is the relation between these three? We have calculated by using dimensional analysis. This is the second use of dimensional analysis. Now we consider here third use. Third use. To find the conversion factor between the units of the same physical quantity in two different systems of units. This is the third use. That is to find the conversion factor between the units of the same physical quantity in two different systems of units. Here, suppose we have to obtain the conversion factor between, suppose we consider here joule and erg. Right, like this. Okay, joule and erg. That is, this is the unit of energy or work. Joule is in MKS or SI system, and erg in the CGS system. We have to obtain the relationship between these two. Now we can write 1 joule equal to x erg. Now dimensions of energy or work, dimensions of work equal to m1 L2 t minus 2. Now I can write here for MKS I will give suffix 1 to 1 1 1. Therefore for joule I can write here, suppose m1 raised to 1 L1 raised to 2 t1 raised to minus 2. Here you see 1 for MKS, 1 suffix for MKS equal to x into m1 L2 t minus 2, and for CGS unit I will write the suffix as 2. Okay, m1 raised to 1 L1 raised to 2 t1 raised to minus 2. This is for joule MK system, and which is equal to x is unknown, m2 raised to 1 L2 raised to 2 t2 raised to minus 2. This 2 suffix for CGS unit, and therefore I can write here x equal to, this is unknown, then I will write here m1 L2 t minus 2, and here m1 L2 t minus 2 I will write here 1, this is 1 1 1, and here 2 2 2. Okay, now suffix 1 indicates MKS unit, suffix 2 indicates CGS unit, and therefore x equal to, I will write m1 raised to 1 kg upon gram raised to 1. See here, this is measured in kg, this is in gram and raised to 1. Similarly, meter upon centimeter raised to 2. L1 is measured in meter, L2 is measured in centimeter, and we can hear second upon second, same unit in MK and CGS, and raised to -2. See here. Therefore, x equal to, now I will write here kg. Kg can be written like this: 10 raised to 3 gram upon gram. Okay. Kg converted into gram raised to 1. Similarly, meter converted into centimeter. Therefore, I will write here 1 meter equal to 10 raised to 2 centimeter upon centimeter and raised to 2, and here only 1. Okay. Then this gram gets cancelled. Okay. Centimeter gets cancelled, and therefore I get here 10 raised to 3 into 10 raised to 2 raised to 2, that means 10 raised to 4, or we can write here 10 raised to 7. X equal to 10 raised to 7, and therefore I can write here 1 joule. 1 joule equal to 10 raised to 7 erg. That means how joule can be converted into erg, or erg can be converted into joules. Or I can write here similarly 1 erg equal to 10 raised to -7 joules. This is the conversion between these two. Okay. That means this is the third use of the dimensional analysis. I hope you all understand this. Thank you.